Good morning, students. Let us discuss Stokes theorem. Stokes theorem relates the surface integral into line integral. So this is your surface integral, which can be converted into line integral, or vice versa. Line integral can be converted into surface integral. Stokes theorem in vector calculus relates the surface integral of a curl of a vector field. So this is a curl of a vector field over an open surface to the line integral of the vector field around the boundary of that surface. In simpler terms, it connects how much a vector field swirls around a surface to how much it flows along the edge to the surface. So mathematical statement of theorem goes like this. We have double integral based on surface curl f dot ds, which is equal to closed integral, line integral, closed integral f dot dr. So it measures the tendency of the field to rotate or swirl at a given point, and this is an integral calculated along a curve. What are the applications? Mainly it is used in physics. Stokes theorem is used in electromagnetism, fluid dynamics, and other areas to relate the field quantities like electric, magnetic fields to their sources or forces. And in engineering, it is useful in analyzing the fluid flow, heat transfer, and other phenomena in which the vector fields are involved. Mathematics, it provides a powerful tool for simplifying calculations involving surface and line integrals. So let us discuss the statement of the Stokes theorem and the proof of the Stokes theorem. Definition. Stokes theorem states that the surface integral can be converted into the line integral. It is defined as the flux of the curl of a vector function A over the surface S of any shape is equal to the line integral of the vector field A over the boundary C of the surface. So let us consider a surface S with C as a boundary. So C as a boundary. So we're going to consider a surface S with C as a boundary. Let us calculate the line integral of the vector function A, around the boundary C of a surface S. Then S equals single integral, this is called contour or line integral or curve. So A dot dr. Dividing the surface. So we are going to divide this surface, whole surface, into large number of parts, S1, S2, S3, dot dot dot, Sk, having boundaries C1, C2, C3, dot dot dot, Ck or Cn respectively. Then this line integral S equals total integral, which is equal to C1, the integral of with respect to C1 is here, with respect to C2 dot 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 Ci dot 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 Cn. Okay, so we can have the summation. So this can be written in terms of summation. So we have summation over I equals 1 to n Ci Ai dri. Okay, so this can be replaced with summation. So we have integral, line integral Ai dri, which is equal to your left hand side. So multiply and dividing by Si. So you are going to multiply and divide by Si. So you are going to multiply and divide by Si. If n is sufficiently large, then the volume Si becomes infinitely small. So Ni tends to infinity, then Si will become 0, almost tends to 0. So we can write, when limit Si tends to 0, we can write this term as curl A dot n cap. So we can write this as curl A dot n cap. So now convert this summation. So convert the summation into integration. So we're going to convert this summation into integration, writing S as ds for infinity small area, so that equation 3 can be written as A dot dr. Well, left hand side is A dot dr. Right hand side is, instead of this you are going to write curl A dot n. So curl A dot n. And instead of summation over S, you are going to replace the integral with ds. So I repeat, see here, this can be replaced by curl A dot n. and summation over s can be replaced with integration with respect to ds. So this can be written as del cross A dot n cap ds. So n cap ds can be written as ds vector. So we have line integral A dot dr, which is equal to double integral surface integral del cross A dot ds vector. So this is your Stokes theorem. Line integral is converted into surface integral and vice versa. So vice versa, surface integral can be also converted into line integral. So this is Stokes theorem. So using Stokes theorem, let us solve some problems. Verify the Stokes theorem for the vector A is given by this. So vector A is given as 2x minus yi vector minus yz square j vector minus y square zk over the upper half surface of the vector. Upper half surface of the vector, it's given as x square plus y square plus z square equals 1. So we know from Stokes theorem, so we are going to prove this one. We are going to calculate, or using this vector we are going to calculate right hand side and left hand side whether they match or not. We are going to calculate. So plane of the circle is given as x square plus y square plus z square. It is given as xy plane. So your z will be 0. So x square plus y square plus 0 equal to 1 as shown in the figure. So we have a plane like this, z equal to 0. So we have x squared and y squared alone exists. Okay. So x squared plus y squared equal to 1, that will give us is the boundary of C. And of course we know r vector equal to xi plus yj plus zk vector. So dr can be written as dxi plus dyj plus dzk. So by Stokes theorem, so we know that by Stokes theorem is given by this. Just take the left hand side. Left hand side of the Stokes theorem is given as a dot dr. A is given as this. Dr is given as this. Okay, dr is given by this expression. So we have a dot dr. So this is your a, this is your dr. A dot dr. It's a very simple one. A dot dr. So that will give us I dot I, j dot j, k dot k. That will give us 1. So we have now I dot I will give you 2x minus yi. Correct? So 2x minus yi. Your j will be 1 minute. So we have now, okay, a dot dr is given as 2x minus y dx. Okay, we'll solve first. Try to solve. So integration 2x minus y dx can be solved using this parametric equation. X equal to cos theta, y equal to sin theta, at z equal to 0, the plane. So we have x equal to cos theta, y equal to sin theta. If x equal to cos theta, just to differentiate, that will give us dx equal to minus sin theta d theta. The angle theta lies between 0 and 2 pi. So we have 0. This is not theta, this is 0. 0 and 2 pi. So your a dot dr can be written as 0 to 2 pi. Instead of x, you are going to substitute cos theta. So 2 cos theta minus, instead of y you substitute minus sin theta. Dx can be written as minus sin theta d theta. Now you multiply this inside. So I have written the same thing. Just multiply this one inside. That will give us minus 2 sin theta cos theta plus sin square theta d theta. Okay. I pulled minus, see this minus sign out. So that will give 2 sin theta cos theta d theta. So this becomes sin square theta. I have separately integrated. See, I have separately integrated. So now 2 sin theta cos theta can be written as sin 2 theta. So you have minus sin 2 theta. Just sin square theta can be written as 1 minus cos 2 theta by 2. So now integrate. So integrating sin 2 theta, that will give you minus cos 2 theta divided by 2. Correct? And integrating this will give you 1 by 2. See, 1 by 2 can be written as theta by 2. Integrating this one will give you cos 2 theta. So before that we can cancel something out. Is it okay? So theta minus sin 2 theta. Okay, now we just substitute. So that's a mistake here. 1 minus cos 2 theta by 2 here. Here this must be, after integration you have theta minus cos 2 theta can be integrated with sin 2 theta divided by 2. So 1 2 is missing here. 1 2 is missing here. Okay, you'll have to write 1 by 2, so I can pull 1 by 2 out. Now 1 minus cos 2 theta, correct? 1 minus cos 2 theta d theta can be written as integration. So theta, you have theta minus sin 2 theta divided by 2. Already 1 2 is out, so this must be 4. So there's a mistake here. There's a mistake here. So now substituting the limits, minus minus plus. Now cos, instead of theta you have to substitute 2 pi. So you have cos 4 pi by 2. Instead of theta you have to substitute the lower limit, that will give you minus cos 0 by 2. Okay, so cos 0 is 1, of course we know cos 0 is 1. So that will give us 1 by 2, minus 1 by 2. What about cos 4 pi, cos 2 pi, cos 0 is 1, cos 2 pi also 1, cos 4 pi also 1. So 1 by 2. Is it okay? Cos 0 is 1, cos 2 pi also is 1, cos 4 pi also is 1. So we have now 1 by 2. So 1 by 2, we have written 1 by 2. This is minus 1 by 2. And here, you have to substitute now 2 pi. Okay, here it is 2 pi by 2. These 2 and these 2 will get cancelled. We have pi. Okay, then you have to substitute, instead of theta, you have to substitute upper limit, that will give you sin 4 pi. Sin 4 pi is 0. Sin 0 is 0. Sin 2 pi also 0. So sin 4 pi also 0. So 4 pi is 0. And what are the lower limits? If you are going to substitute the lower limit, that will also will give you 0 0. So we have now 1 by 2 minus 1 by 2 plus pi, and this one will cancel. We have pi. So we have pi is the answer for left hand side. So now we'll have to go for the right hand side. Right hand side after Stokes theorem. So right hand side is curl A dot ds. So del cross A. So we have ijk partial d by dx, d by dy, d by dz. So we have a vector here. So we'll have to write 2x minus y z squared minus y z squared minus y squared z. As usual, we can have a matrix simplification that will give you I d by dy minus y squared z minus d by dz minus y z squared minus j d by dx d by dx, this one, and multiplied by this minus y squared z minus d by dz dx minus y. The last term will be your k vector. We have d by dx multiplied by this term minus d by dy multiplied by this term. So we can differentiate with respect to y here. So we have minus 2yz. Okay, differentiate with respect to z, that will give you again minus 2yz. So this will go with 0, minus 2yz plus 2yz. There is no x term here, there is no z term here, so answer is 0. Okay, with respect to x, you will have to differentiate. There is no x term here. With respect to z, you will have to differentiate. There is no x term here, so this will become 0. What about here? Again, there is no x term here, so answer is 0. Here we have y term alone here. So 0 minus 1. Already one minus is there, so plus 1. Can it out? Okay, so we have now 0, 0. Here it is k vector. So del cross A is nothing but your k vector. Is it okay? So we have found out now curl A. Curl A. So substituting in the right hand side of the Stokes theorem, that will give you del cross A dot ds equal to del cross A. We have found out k vector. What about your ds vector? ds vector is written as n cap dot ds. Okay, we are going to consider only xy plane. So we have now ds can be written as dx dy. What of the other one? N cap will be the projection of this. So we have now xy, so dx dy will be here, and n cap is the perpendicular to this swirling. Del cross A is defined as A cross B, and your n cap will be always perpendicular to both A and B. Is it okay? So now dx dy is there, your n cap will be perpendicular to this. Perpendicular means we have only k vector alone exists. You have I vector, j vector and k vector. K will be always perpendicular to I and j. So that's why dx dy n cap is replaced with k vector. So instead of ds vector, you have k vector dx dy. Of course, k dot k equal to 1. So we have dx dy. Is it okay? So we will now substitute the limits now. X square plus y square plus z square equal to 1. but we know that z equal to 0 for the plane, so we have x square plus y squared equal to 1, and of course, so y equals plus or minus root of 1 minus x squared. So y will have the limit minus root of 1 minus x squared to plus root of 1 minus x squared. Substituting now y equal to 0, you have x squared equal to 1, so x equal to plus or minus 1. Okay, so x will have a limit minus 1 to plus 1. So okay, this is what we have done earlier. Okay, for solving double integral problem, we did like this. For z equal to 0, we have this limit for y. Okay, y will have the limit with respect to x. Then y equal to 0, that will give you x squared equal to 1. So x equal to plus or minus 1. So x will have a limit minus 1 to plus 1. Is that okay? We have done already so many problems. So we have x equal to minus 1 to plus 1, and y equals plus or minus root of 1 minus x squared. So minus root of 1 minus x squared to root of 1 minus x squared. So dx dy. So it's easy to integrate now. So we have now ds. I have written separately. This dx is extra. I have written extra. It's wrong. We have dx here. Dy alone is here. Okay, there is no dx here. So this is wrong. Okay. So we have dx here, dy alone. So integrating dy will give you y. So y will have the limit minus root of 1 minus x squared to plus root of 1 minus x. So you have to substitute upper limit first, minus of lower limit. Minus of minus lower limit. So that will give you plus. So 2 times. This is 2 times. So 2 times I have pulled 2 out. So that will give you minus 1 to plus 1 dx root of 1 minus x squared. So when you are going to see, whenever you see this kind of problems, you have to substitute only the parametric equation like this. So substitute x equal to cos theta, that will give you dx equal to minus sin theta d theta. For x equal to 0, then theta will become pi by 2. For x equal to 1, theta becomes 0. I repeat, see here, x equal to cos theta. Okay, so your dx should be replaced by dx equal to minus sin theta d theta. Similarly, you have to change the limits also. What are the limits? Here it is in terms of x. You have changed now in terms of theta. So you have to change the limits also. So now x equal to 0, substitute x equal to 0 here, x equal to 0. For which value theta will become x equal to 0 here? Cos 90 is 0. Cos 90 is 0. So cos pi by 2 is 0. So that's why theta becomes pi by 2. Again you have to substitute x equal to 1 here. 1. Cos 0 is 1. So that's why theta equal to 0. Is it okay? So you have now, so instead these limits are in terms of x, these limits are in terms of theta. So don't forget this one. These limits are in terms of x. We have changed into theta. So limit should be changed to pi by 2 to 0. See, look at the limits now. It is 0 to 1. Here it is pi by 2 to 0. So now root of 1 minus can be written as root of 1 minus cos square theta. Root 1 minus cos square theta is sin square theta. So root of 1 minus cos square theta, root of sin square theta, that will become sin theta. Sin theta. I repeat, root of 1 minus, instead of x squared you have to substitute cos square theta. 1 minus cos square theta is sin square theta. Under root, that will give you sin theta. So sin theta. Not clear. Root of 1 minus x squared. So x is nothing but cos theta. So 1 minus cos square theta. 1 minus cos square theta is nothing but sin square theta. So under root, that will give you sin theta. Okay. So now dx is nothing but minus sin theta d theta. Minus sin theta d theta. So we can pull this minus sign out. So that will give you here minus sign, extra equal is there. So we have minus sign 4 sin square theta d theta. I can remove this minus sign by changing the limits. So I will change the limits now. Instead of pi by 2 to 0, I will change into 0 to pi by 2. So we have now 4 sin square theta can be replaced by 1 minus cos square theta by 2 d theta. So now easily we can integrate. So I have written the same thing. We can integrate. So integrating these 2 and this 4 will get cancelled. Correct? We have now 2. Now we have 1 minus cos 2 theta. When you are going to integrate, that will give you theta. Cos 2 theta can be written as plus minus sin 2 theta by 2. Now it's correct. See, minus sin 2 theta divided by 2. So that will give you plus minus minus plus. So plus sine 2 theta divided by 2. Now we have to substitute the limits now. So when you are going to substitute the first limit, upper limit, that will give you pi by 2. Lower limit will give you, here it is 0, sine 0 is 0, so pi by 2. And 2 will get cancelled, we have pi. So which is nothing but your left hand side. Left hand side already we have calculated the left hand side, which is nothing but pi. So right hand side also you have pi. So Stokes theorem is verified. Right hand side equal to left hand side. So we have calculated both the terms, both the values are pi. So thus the Stokes theorem is verified. Okay. So let us go for the next problem. Verify Stokes theorem for f equals y minus z plus 2i vector plus yz plus 4j vector minus xz k vector over the open surfaces of the cube. So here it is a cube. What are the limits? For a cube we have 6 sides, 3 axes. Okay, x equal to 0 to x equal to 1, y equal to 0 to y equal to 1, z equal to 0 to z equal to 1. So very important thing is xy plane is not included. So you have to remember this one. So we have 6 faces for any cube, but here it is given as xy plane. So one plane is not included. So instead of 6 faces, you have to write only 5 faces. Is it okay? So it's given as not included in the xy plane. So we have one plane. Totally we have 6 faces. 6 planes are there for any cube. So but it is given as one plane is not included. So we are going to write only 5 faces. So we are going to remove one plane. So now using Stokes theorem. So we have Stokes theorem, which is given by this. F is given as this. We know that already del equals I partial d by dx plus j cap partial d by dy plus k cap d by dz. First we will go for right hand side. Right hand side is del cross f. So we will have to find out now del cross f, find the expression, find the value. Then we will go for left hand side, whether they match or not. Suppose if it matches, then we can say that it is satisfied with the Stokes theorem. So del cross f, f is given as this. You substitute here for f, and simplifying you will have I vector I cap d by dy minus xz d by dz minus d by dz yz plus 4 minus j d by dx minus xz. Okay, correct? This multiplied by this will give you this, and plus k, this with this minus this with this will give you this. Okay, so now there is no y term here. So answer is 0. With respect to y, you have to differentiate, so answer is 0. Here it is, z is there. So you have minus y, and of course this becomes 0. What is the next one? You have minus z. See here, minus z. When I will differentiate with respect to z, that will give you, this is 0, this is minus 1, this is plus 2, correct? No, 0. Okay, constant. When I will differentiate, so that will give you 0. So here it is 0, minus 1, again 0. So answer is minus 1. So there is no x term here, answer is 0 here. And here it is y term alone is here. And this will become 0, this will become 0. So we have minus 1, so minus 1. So we have del cross f is nothing but minus yi plus zj minus j minus k. You pull j alone out, so that will give you z minus 1 times j vector. So your del cross f, we have found out del cross f. Del cross f n dot ds, correct? N dot ds, that is a formula. Del cross f n dot ds, that's a formula. So now right hand side is del cross f n dot ds. As I said earlier, that in the problem it is given as xo plane is not included, correct? So not included in the xo plane. So this is your whole diagram of a cube. So we have now cube. Just take the origin here. X coordinate is here, your y coordinate is here, your z coordinate is here. Okay. So here it is 0, 0, 0, and this must be 1, 0, 0. So for x it is 0 to 1, for y also it is 0 to 1, for z also it is 0 to 1, 1, 1, 1, from 0, 0, 0 to 1, 1, 1. So this is origin O, and here 1, 0, 0. Is it okay? And similarly here for the y we have 0, 1, 0, and for the z we have 0, 0, 1. Is it okay? For the 3 axes. So we have now, this is 0, 0, 0, this is in the x direction, so it must be 1, 0, 0, this is in the y direction, so 0, 1, 0, this is in the z direction, this point must be 0, 0, 1. Is it okay? Now this is your x and this is your y. So this is your xy plane. So this plane we are not going to consider. Is it okay? So this plane, this area we are not going to consider. This plane. So this is x, o, y plane. We are not going to consider. And we are going to consider all the other 5 surfaces, 5 faces we are going to consider.